So we're gradually getting through this now. However, the next thing for us to look at is going to be creating a drop target set. So essentially a set of letters that exist within the world that sit along some sort of rail. When each letter is taken out, they eventually give you a multiplier to your overall score from that point on. So the player's aim is going to be to knock down each of these letters. Now, I'm going to use this as a good opportunity to teach you about child actors, which is a great way for us to basically create one actor that can, in its construction script, generate many other actors that will then be placed within the world. So what we're going to do that is we're first off going to create a variable band that is a simple blueprint that will have a starting position, an ending position, and a band between the two. At which point we're then going to have, after the variable band is created, a single drop target created, which is going to be a single object that has a letter on it. And then we're going to create a drop target set, which will be a blueprint that is based upon variable band that will basically create a variable band. You type in a word and it will then automatically create drop targets to the size of that word along its frame. So let's begin. Now the first step that we're going to have is we're going to need to import some assets. And what I'm going to do at this point is I'm going to implement the assets that are called SM post half. And the other one that I'm going to need to make sure that this works is SM band extender. So I'm just going to click on SM post half, and I'm going to scroll up to SM band extender, control click. I'm then just going to drag those two into import all. Default here should be fine. I'm just going to double click and check that the collision on this asset is fine. That should be correct. And also I'm going to go to my band extender, view collision. That'll actually be fine because we never expect the ball to go up or in between these, so that's totally fine. So from here on in, we're going to go to blueprints, I'm going to right click, and we're going to create ourselves a new blueprint actor. Now this blueprint actor is essentially going to be running a construction script that will create two ends and then a piece between the two of them. So I'm going to create a new actor, and I'm just going to call this BP underscore variable band. Let's open it up. And now, once it's up, let's have a look at what we have here. So at the moment, there's no asset here. It's just the default scene root. So I'm going to add a static mesh component. And this is going to be called post1. So post1 is going to be set to post half, at which point you'll have this. I'm going to compile, save, and then I'm going to go to my construction script. Now within my construction script, what we want to do is we want to essentially have a location in the world that is going to be the post location. We're then going to set post 1's rotation to face that location. We're then going to add a static mesh at that location, which will be the secondary post. And then finally, we're going to add a static mesh that will stretch between the two of them, that will be the band itself. So the first part there is going to be for us to add a variable that will be called post location, and it's going to be a vector. Compile, save. Now this vector is going to be set so that it can be editable, and as well as that I'm going to show the 3D widget. Finally, I think I'll set the X to be by default 200. Compile, save. Now if I look at what that looks like in the world now, I can drag this in, and you'll see that we have this nice little post location widget here. And I can drag it around, although right now it won't do anything, but that's okay. So the next element is going to be getting this asset, post 1, getting post location, which is the area that we want to work with, where the new post will be created, and essentially all we're going to be doing is set rotation of post 1. You can see the one is called set relative rotation, at which point I'm going to simply drag off of post 1, get relative location, and then there's a nice little function called find look at rotation, and I'm going to connect that to post location. So it's going to find the rotation that is required to look between this position and this position. And if I was to then connect this to here, compile, save, you'll notice that now in the world, wherever I put this part of the widget, this is always going to face it. Do you see how that's rotating to face our actor? So that's the first step. Now that we've done that, we're going to create a new static mesh component. So I'm going to right click and add static mesh component. At which point the relative transform is going to be equal to the post location, and the rotation by default is going to be set up as a opposite of this find lookout rotation. So I'm going to get my relative transform, and what I'm going to do is I'm going to drag off of it and type in the word make. Now it needs a few things here. First off, we have a location, which is easy, so I'm going to connect post location to the location. The next section is it's going to require a rotation, so I'm going to get my find lookout rotation, but this time instead of looking from the relative location of post 1 to the post location, I'm going to do it the other way around because we're going to be looking backwards. So I'm going to get this, and I'm just going to duplicate these so it's just a little bit cleaner in the graph. Connect those two, and I'm just going to set that as a rotation. So with those two in mind, compile, save. If I was to look at my viewport, we're missing one thing. And what we're missing here is we don't actually have the mesh set. So while I could set this mesh manually by clicking here and then just plugging it in, I think it's a good idea for us to make sure that the two posts always match one another. So I'm going to drag in a reference to post 1, and off of the static mesh component, I'm going to type in set static mesh. At which point, I'm going to connect this to the mesh of post 1. Post 1 is a static mesh component reference. So I need to drag off of that and say get static mesh to find the actual mesh involved. And now, upon connecting those, compile, save, you'll notice that we now have a post here and a post here, and in between them we have nothingness, but they're actually facing one another. So wherever I move this widget to, it's going to automatically face home, which is exactly what we want. So how do we put the band between them? Well, that's rather simple. If I was to look at the band extender, you can see with how this is set up in the world that this comes directly from here. And what that means is we can actually do an offset directly from that location. So we can add the band extender in and automatically just stretch it across. I'll show you how that's going to work in just a moment. So within variable bend, what we're going to do is we're going to once again add a static mesh component. So I'm going to right click, add static mesh component. I'm going to connect these two up. And all I'm going to do here is I'm going to set this. I know I do want this to always be the band. So I'm going to just set it to band extender. Now its relative transform is going to be the same transform as post 1. So I'm going to get this, drag it in, and I'm just going to say get relative transform. So now that that's set, what I'm going to do is I know band extender is exactly 100 units long. So from here to here is 100 units, which means at a scale of 1 on the x-axis, it is 100 units long, which allows me to do the math backwards to work out what scale it would need to be to connect the two locations. And that's actually rather simple math here. All I need to do is get the static mesh component, and I need to set the relative scale 3D. And the scale is going to be equal to the Y and Z scale. So I'm going to drag off of this transform and just do a break. And I'm going to split the scale, and I'm going to split this scale as well. Now the reason I'm doing this is when I set the scale here, I want my Y scale and my Z scale to be exactly what I had them set as. However, I want my X scale to be equal to, this is where the math comes in, it's going to be equal to post 1's relative location, so that relative location, minus, so vector minus vector, the post location. So by getting those two and subtracting one from the other, and then getting the length, oops, not get path length, get vector length, it actually tells me how long the distance is, like how far the distance is between those two locations. I'm just going to add some reroute nodes here so I can make this a little bit neater. And because that tells me the distance, all I need to do is divide that by 100, which we know is equal to a scale of 1, and connect it to here. Now, compile, save, and if I look at this, you can now see that wherever I put this asset, it's automatically extending the band between those two locations, which is fantastic. The final thing that I need to do here to make everything okay is to simply go into the actual assets themselves and set them up to be just a little bit prettier. So I'm going to open up the band extender. I'm just going to set it to be white, save. I'm also going to set post half to be equal to, we can see what each of these are if we're not sure, remember that. So I can go highlight this, So that's the main base. I'm going to tell this to be blue. I'm going to tell this to be white, same as the other asset. So simple white. And finally, I'm going to tell this section here to be simple metal, which is the cap. Save. And now if I see them in the world, I have a rather simple asset that we've just created that will automatically suit itself to the situation. Now the next element is going to be adding the child actors to the variable band to automatically place themselves along this line here.